Okay, I want you guys to do the next, do C and D in your pairs. Okay, so we should have gotten the x squared by itself. And most of us were able to do this. So I get x squared equals 24 divided by 3 is 8. Then when I square root it, I would get x equals, do I know the square root of 8? No, so it's just the square root of 8. And make sure you have 2, negative square root 8. Okay, so again, we're going to just square root both sides here. And I'm going to get x minus 2 equals, do I know the square root of 24? No, square root of 24 and negative square root 24. I then would add the 2 to both sides. And I'm going to get x equals 2 plus square root 24 and 2 minus the square root of 24. And I think that turned out to be 6.9. And what was the other one? Negative 2.9? I don't know, let's see. Oh yeah. Any questions over that? We're all good? Okay, next ones. So I'm going to substitute in my 0. I'm going to get 2 times x minus 3, the whole thing squared, plus 20. I'm going to subtract the 20 from both sides. That's going to give me negative 20 equals 2 times x minus 3, the whole thing squared. Now what would I do? No. Divide. Order of operations states I would do what first? Exponents, then multiplying. So if I distributed, I'd be outside of, I wouldn't be following the order of operations. So what I'd have to do is multiply that out first, then multiply by the 2. Okay, so I don't want to do that. I want to get rid of that 2, so I don't have to deal with multiplying this whole thing out. So I need to divide both sides by 2. So that's going to give me negative 10 equals the x minus 3 squared. Now I can square root. Do I know the square root of negative 10? No. What's wrong with that? Yep. It's imaginary. Remember this right here tells me it's imaginary. A negative inside the radical means it doesn't really exist because no number times itself will give me a negative number because a negative times a negative is a positive. So what this is I square root 10 and negative I square root 10. And that equals the x minus 3. So then I'm going to add the 3 to both sides. And I'm going to get x equals 3 plus I radical 10 and 3 minus I radical 10. Okay, make sure you have that imaginary number. Now, what does that mean? Okay, when we solve a quadratic, we're looking for the x-intercepts. So what does that mean if my answer is imaginary? It doesn't exist. That means that you don't actually have x-intercepts here. If I were to graph this, let's think about this. This is in vertex form. So my vertex would be 3 and 20. So I'd be way up on my graph, kind of up here somewhere, right? And it would face up, and it's got a stretch of 2. It went to the right 3 and up 20. Would this parabola ever cross the x-axis? No. So that's how I can see that it's going to have imaginary solutions, because there are no x-intercepts here. So we're going to write this down. If the solutions are imaginary, that's what an imaginary solution for a quadratic tells me. That although I can solve it, it really doesn't have x-intercepts. Let's do the next one. Okay, do that one in your pairs for me. Okay, so most of us got here where I have x squared equals -9. Do we all get that far? Okay, good. We square root both sides. Okay, do I know the square root of -9? It is imaginary, so it should have an I. What's the square root of 9? 3. So it's 3i. And very good, my -3i. We need both. Remember, 2 answers. Most of the time when we're solving a quadratic, we'll get 2 answers. 2 x-intercepts. Any questions? Okay, we'll skip G and we're going to go to the back. And we're going to jump out of a plane now. I have not. I don't necessarily think I want to. I don't know. Okay, but smoke jumpers are firefighters who jump out of planes into fires to help put out the fire. Okay, so smoke jumpers are in a free fall from the time they jump out of a plane until they open their parachutes. The function h of t equals -16t squared plus 1,600 models a jumper's height h in feet as a function of time at t seconds for a jump from 1,600 feet. How long is the jumper in free fall if the parachute opens at 1,000 feet? Okay, in this case, I'm not asking you for the x-intercepts, really. because I'm not asking when I'm going to hit the ground, because I don't want to hit the ground at the speed at which I jumped out of the plane. Okay. I would like to open my parachute. So they're wanting to know how long it's taking me before I open my parachute. And again, I'm not going to open my parachute on the ground. I'm going to open it in the air. So what they're saying is, if h of t equals 1,000, what is the time? In this case, t. So in this time, instead of plugging in 0 for h of t, we're going to plug in 1,000 equals the negative 16t squared plus 1,600, or 1,600. Okay, we are then going to solve. So I'm going to subtract this 1,600. I'm going to get negative 600 equals the negative 16t squared. Then I'm going to divide by negative 16. A negative divided by negative is going to make that a positive. So I have 37.5 equals t squared. Then I'll square root. I'm going to get t equals and since I don't really understand what the square root of 37.5 is, I kind of want an approximate value, so that makes sense to me. And so the approximate value is 6.1 seconds. So the parachute opens at 6.1 seconds. Any questions over that? Now, do I need the negative 6.1 seconds? No. Right, that doesn't make sense. I would never say, you know, that I traveled for negative 6.1 seconds. Yes. The square root of 37.5. I used my calculator, plugged in my calculator, square root of 37.5 was 6.1237243. So I ran into the nearest tenth. Okay. Any other questions? Okay, next one we're going to graph. Okay, where does f of x equal h of x? Okay, we're solving a systems of equations. We just graphed quadratics. So we're going to graph these and see where they intersect. So the first one, I need the vertex. Okay. Josh, can you give me the vertex for that quadratic?
Oh,
negative 4 and negative 3. Perfect. So your x is negative 4 and y is negative 3. Then we need the a value. Aaron, what's the a value here? Not the a value. That's the h value. What's the number right here? Not 0. 1. So imaginary 1 in front. Okay. So we're going to go a over 1. then 3a over 1, then 5a over 1. That's our pattern rate of change for quadratic. So I go to the right one and up 1, left one and up 1. Then to the right one and up 3, left one and up 3. Right one and up 5, left one and up 5. So this is my wonderful parabola. Any questions over that? Okay, then we want to graph this linear equation. We have to remember back to math 1, we're assuming you already know how to graph a linear equation. I think you probably even graphed linear equations in math 8. 8th grade math, right? So we need, it's y equals mx plus b. The m is the slope. The b is the y-intercept. Remember that? So class, what is, you want to start with the b. What is the y-intercept here? 3. So 3, and it's on the y-axis. That's where we begin. Not negative, sorry. I just graphed -3. I want +3. There we go. Then my slope tells me how to move. What's my slope here? The number in front of x. 1 over 1. So I rise 1 and run 1. Remember that? So up 1, right 1, up 1, right 1. I could also do -1 over -1. So down 1, left 1, down 1, left 1, down 1, left 1, down 1, left 1. I'm going to do as many as I can to make sure I have a nice straight line. Okay, then all I need to do is find what are the x values where they intersect. X equals -2 and -5. That's where those two are equal. Okay, your homework